Welcome everyone. Today I'll be talking about web service testing, a crucial process in ensuring that web services function correctly and reliably. As we begin, you can see an image illustrating the idea of carrying a global load, which represents the importance and reach of web services in connecting systems worldwide. My goal is to guide you through the key concepts and practices that will help you understand how to effectively test these services. If you have any questions along the way, feel free to reach out to me via the email provided. Let's get started. We'll start by covering the fundamentals of web service testing, exploring what it entails and why it's critical to ensure service reliability and performance. Then, we'll look at some of the popular tools commonly used in the field, discussing the unique benefits each one offers to streamline testing processes. After that, we'll dive into enhanced testing practices with practical examples and a visual representation to help clarify these concepts. Finally, we'll discuss real-time project insights to show how these methods apply in actual scenarios, and wrap up with some closing remarks to summarize the key takeaways. This roadmap will help us stay focused and make sure every part of the training is clear and actionable. This training will give you a strong foundation in web service testing, covering both the basics and the more advanced techniques used in the field. We'll also introduce some of the most popular testing tools that help make the testing process more efficient and dependable. Beyond just theory and tools, we'll look at how to apply what you learn in real-time projects, so you can see how testing fits into the integration process and supports the development lifecycle. This combination of knowledge and practical application will prepare you to handle testing challenges effectively and contribute to better software delivery. A web service is an application that doesn't have a graphical user interface, meaning it works behind the scenes. It operates with an engine that takes input formatted in XML, processes the data, and then provides the output also in XML format. XML is used to tag and structure the data so it's easy to understand and exchange. The communication happens through SOAP, which is a protocol used to transfer the data securely over the internet. To describe what services are available and how to interact with them, WSDL is used. It essentially acts like a contract detailing the service's functionalities. Finally, UDI serves as a directory that lists all the available web services, making it easier to locate and use them. The image here represents how different devices like laptops, smartphones, and tablets connect to these cloud-hosted services, illustrating the universal access web services provide across platforms. In a typical web service environment, there are three main components that interact to make the service work. The service provider is the entity that creates and publishes the web service, making its details available to a service broker or registry, often known as a UDI registry. This broker acts like a directory, helping service requesters or clients find the web services they need. Once the service requester finds the web service through the broker, they download the WSDL document, which describes how to interact with the service. Finally, the requester uses this information to invoke the web service, sending requests and receiving responses formatted in SOAP or XML. This flow ensures that services are easily discoverable, understood, and accessible across different systems on the network. Before we dive deeper into testing itself, it's important to know what materials you'll need to effectively carry out web service testing. Gathering these resources ahead of time sets a solid foundation for smooth and organized testing processes. Let's move forward with a clear idea of what you should have ready. Web services play a crucial role in enabling different systems to work together smoothly and improving the overall experience for users, especially in today's API-driven world. Testing these services is essential to ensure that data stays accurate and secure as it moves across various systems, helping to prevent errors and potential security breaches. Performance testing is equally important, as it checks how responsive and stable the web services are, which helps avoid failures that could be costly when the services are live. Considering that about 70% of digital interactions rely on APIs, thorough testing is necessary to keep digital experiences dependable and seamless. The image here highlights this by showing the testing process in action. emphasizing the importance of finding and fixing bugs to maintain security and smooth operation. Functional testing ensures that web services respond correctly to all request types by validating inputs, API responses, and user interface interactions. Load testing checks how well the service performs under heavy traffic by simulating many users or transactions, helping identify any stability or speed issues. Security testing looks for vulnerabilities that could be exploited by attackers, while compliance testing makes sure the service meets all necessary regulations and data privacy standards. Automation plays a key role in running repeated regression tests efficiently, supporting continuous integration processes to reduce errors and deliver updates smoothly. Together, these testing types cover essential aspects of reliability, performance, and security for modern web services. Let's take a closer look at how a web service typically operates. The workflow begins when a client sends a request, often formatted in XML or JSON, to the web services engine. This engine processes the input by executing the necessary business logic or accessing data sources. Once the processing is complete, the engine generates a response and sends it back to the client in a structured format. This cycle enables seamless communication between systems, allowing different applications to interact without needing a direct user interface, which is essential for creating interoperable and efficient services in today's digital environments. SOAP UI offers a comprehensive approach to API testing by covering functional, security, and compliance aspects for both SOAP and REST APIs. It includes advanced features like complex assertions, data-driven testing, and scripting, which allow deeper and more thorough test coverage. This makes it especially popular among enterprises that need detailed SOAP validation, particularly when working with legacy systems where accuracy and robustness are critical. The tools and features provided by SOAP UI help ensure that APIs operate correctly, securely, and in line with industry standards, supporting the overall stability and reliability of web services. SOAP responses are organized in a clear hierarchy, starting with the envelope, which acts as the outer layer defining the boundaries of the entire message. Inside the envelope, you'll often find a header which is optional and includes metadata like authentication, transaction, info, or routing details, though some services may leave it out depending on policies. The core of the message is the body, containing the actual payload or, in case of errors, fault information. Testers rely on the body to extract results, verify success, or identify errors. Tools like SOAP UI enhance how we work with these responses by improving readability and allowing the use of XPath to validate specific parts of the message, helping to build strong assertions and troubleshoot issues efficiently. Extensible Markup Language, or XML, is a way to structure data so that both humans and machines can read it easily. It acts as a flexible format to store data and also to exchange information between different systems. One key feature of XML is that you can create your own tags, which means you define the rules for how your data is organized and interpreted. For example, you might have tags like first name, middle name, and last name to represent parts of a person's name inside a parent tag like personal data. This flexibility allows systems to communicate using a customized protocol tailored to their specific data transfer needs, making XML a powerful tool in web services and data integration. In working with web services, one common challenge is understanding the exact format of the input XML that the service accepts and the output XML it returns. We also need to know which specific services are available within a web service. This information is all clearly laid out in a document called WSDL, which stands for Web Services Description Language. WSDL is an XML-based language designed specifically to describe the functions and details of a web service. It provides a structured way to specify the expected inputs, the outputs, and the service endpoints, making it easier to interact with and test the web service. So, when you're testing or integrating with a web service, you rely on the WSDL document to guide your requests and understand the responses. Types of WSDL operations to understand how messages are exchanged between a client and a web service. The one-way operation allows the service to receive a message without sending any response back. Request response is the most common type, where the service receives a request and returns a response. Solicit response is the reverse, where the service sends a request and waits for a response from the client. Lastly, notification operations involve sending a message without expecting any reply. These operation types help define the interaction pattern and behavior for web services described in the WSDL file. SOAP is an XML-based protocol used to enable communication between applications over HTTP, allowing them to exchange information regardless of platform or programming language. It stands for Simple Object Access Protocol and serves as a format for sending messages. On the other hand, WSDL, which means Web Services Description Language, is also XML-based, but focuses on describing the services offered by a web service and how to access them. Unlike SOAP, WSDL is an XML document used to locate web services and define their operations. While SOAP handles the actual messaging and communication, WSDL provides the details about the service's capabilities and interfaces, making it easier for applications to understand what the service offers and how to interact with it. Both are essential components in web service integration, with SOAP ensuring message exchange and WSDL guiding service discovery and usage. First, you need to understand the WSDL file because it describes the web service's available operations and how to interact with them. Then, identify which operations the web service provides to know what actions you can perform. Next, it's important to learn the XML request format you must send to communicate correctly with the service. Equally, you should determine the expected XML response format to validate the results accurately. Finally, you can use tools like SOAP UI or write your own code to send the request and verify if the response matches what is expected. This process helps ensure that the service works correctly and meets requirements. Now, let's look at how SOAP UI fits into the workflow for testing web services. SOAP UI is a tool that allows us to interact with the WSDL to send requests and receive responses, making it easier to test and validate the different operations defined. It helps us build and run test cases by creating the necessary XML requests based on the WSDL description, enabling us to verify that the web service behaves as expected. Using SOAP UI, we can efficiently test various request-response scenarios, check the accuracy of data being exchanged, and ensure the service meets the required standards before deploying it. This completes the testing process by connecting what we learned about WSDL and XML with practical execution. In this test case structure for the patient health management system, we focus on the process of transferring patient data from the lab to the hospital and then to the registry. The test suite is named Patient Data Transfer, and the test case we're looking at is called Lab-to-Hospital to Registry. The first step involves simulating a lab callback using a mock post request to the lab's results endpoint, which can be either from a mock service or an external call. After this, we use a property transfer or Groovy script to extract the needed data to prepare for the next REST requests. These REST requests simulate the data flow through the system, and assertions are added after these steps to validate that the responses and data handling are correct. This structure ensures that each step in the data transfer from lab results to hospital systems and finally to the registry is thoroughly tested for accuracy and reliability. To begin testing with SOAP UI, start by opening the application and creating a new SOAP project. Name your project, for example, PHMS API test. Then, you need to import the WSDL file by entering the initial WSDL URL, such as the patient service WSDL link provided. After clicking OK, SOAP UI will automatically generate all the available services and operations defined in that WSDL. Next, you move on to selecting the specific operation you want to test. Within the PHMS system, you might see operations like create patient, get patient details, schedule appointment, update medical record, or cancel appointment. For example, to test creating a patient, you would expand the FEMSA project, then the patient service, and select the Create Patient request to start working with it. This basic flow shows how SOAP UI helps streamline testing by generating the necessary request templates based on the service definition, allowing you to focus on validating operations relevant to your test case. In this step, you update the XML request inside the request editor to provide the necessary patient details. For example, you would enter the patient's first and last name, date of birth, gender, phone number, and insurance ID within the Create Patient Request tags. Once you've updated the XML with the correct data, the next step is to select the appropriate operation and submit the request by clicking the Run button. After submission, SOAP UI will process the request and return a response in XML format. This response indicates whether the operation was successful and includes the patient ID generated by the system, such as PHMS 10234. This process allows you to verify that the patient creation is functioning properly and that the data is being registered as expected. Postman offers a very straightforward way to test APIs quickly, thanks to its intuitive interface, which lets you manage different environments efficiently. It also includes collaborative features that allow team members to share test scripts and API documentation easily, improving how teams work together. Moreover, Postman integrates well with DevOps practices, fitting smoothly into CI/CD pipelines to automate and streamline testing throughout the development workflow. Given its ease of use and powerful features, it has become highly popular, with over 17 million users worldwide relying on it as a go-to platform for API development and testing. The screen here shows a typical Postman workspace where you can run API requests, view responses, and collaborate in real time with team members, making it clear why Postman is widely adopted in the industry. Catalan Studio offers broad support for automated testing across web, mobile, and API applications, all within a single platform, which simplifies managing different types of tests. It features an easy-to-use scriptless interface that lets testers create and run tests without needing deep coding skills, making the process more accessible and faster. Additionally, it integrates smoothly with popular continuous integration and delivery tools like Jenkins and Docker, helping teams automate their testing workflows and maintain efficient, reliable releases. This combination helps streamline testing efforts while supporting collaboration and consistency throughout the development cycle. Rest Assured is a valuable tool for Java developers working with RESTful APIs because it simplifies the testing process by providing a clear and fluent domain-specific language. It supports behavior-driven development-style tests, making the tests easy to read and understand, which helps improve teamwork between testers and developers. Additionally, it integrates smoothly with popular testing frameworks like Junit and TestNG, so you can build reliable and maintainable test suites without extra hassle. One of its key strengths is the ability to validate HTTP responses in detail using very little code, ensuring that API behavior is accurately checked. The image here shows example tests written in Java using Rest Assured, demonstrating how straightforward it is to send requests and then assert both status codes and response content, all within a familiar testing framework environment. JMeter is a powerful tool that lets us simulate heavy user loads to see how web services handle high traffic. This helps us pinpoint where system bottlenecks occur by analyzing performance under stress. It also supports distributed testing, meaning we can run load tests across multiple machines to mimic large-scale user activity. Many organizations rely on JMeter for flexible and thorough performance benchmarking, making it easier to ensure their web services are reliable and efficient before going live. The image shows a live load test scenario with CPU, response time, error rate, and network latency metrics, illustrating how JMeter helps monitor system performance in real time. Thank you for following along with the presentation. I hope the overview of different tools and testing methods has given you useful insights into how to approach API and performance testing effectively. If you have any questions or want to discuss any of the topics further, I'm happy to help.